Hey, 11th graders. So last time we saw each other, we learned about non-right triangle trigonometry, and we focused on law of sines and law of cosines. We're going to continue talking about non-right triangle trigonometry, and this first example right here is just combining the two together. So we had very specific instances where we only used law of cosines or only used law of sines, and sometimes it's hard to tell which one we're going to use when. And my biggest recommendation, my biggest hint for you is try one of them. You will find the one that won't work. If you plug it in and you notice that you have more than one variable, I think we talked about this last time. Um, Maybe we didn't. But if you plug it in and you find that you have more than one variable when you go to solve, then you used the wrong one and then you try the other one. We only have two ways to solve for non-right triangles, law of sines, law of cosines. So if one doesn't work, then the other one should. And then if they both don't work, then we're missing something and we need to go back and reassess. But that's part of the problem solving process is just try something, anything, and see if it works. So for this triangle, we're going to find the length of x. And maybe we wanted to use the law of cosines here. And so if I wanted to use the law of cosines to solve for x, the cosines relationship is very much a side and its opposite angle, kind of like law of sines as well. But we would do x squared equals, and then remember the two side lengths doesn't matter which one is which. So we could do 18 squared plus 30 squared minus 2 times 18 times 30 times cosine of 27. But let's, for instance, say we saw two angles and we're like, law of sines. And we did sine of 27 over x. Awesome. Well, the only other angle that we have is sine of theta over 30. And maybe we set that one up. And then we would get stuck because we set it up and we noticed we had two variables, x and theta. So we have too many things to solve for. And so that's when we would be like, oh, okay, use the wrong one. I need to use law of cosines instead. So, yeah. We can go ahead and plug this into our calculator. I believe that you can solve for this on your own. We get that x squared is equal to something. I don't have it written down, but we get that x is eventually equal to or approximated to 16.2 meters. Don't forget to take the square root at the end, right? So maybe you had something different than that squared of this. Don't forget that when you solve for this right-hand side, you're getting x squared equals that. So we need to make sure that we then take the square root. Okay, now we want to solve for the angle, and we just said, okay, that's approximately 16.2. So I would recommend with geometry always kind of putting those values into the diagram if you can. Now we want to solve for the angle, and so we could use law of cosines. We could absolutely use law of cosines to solve for this angle, right? That'd be cosine of theta equals, and it's 16.2 squared plus 18 squared minus 30 squared all over 2 times 16.2 times 18. Now we could have used law of sines as well to solve for that angle, but law of cosines already in your formula packet gives you this formula, right? Where it says cosine of theta equals. Law of sines in your formula packet doesn't isolate for that trig function. And so you would have to isolate for that trig function on your own, which you're totally capable of doing. It's just a little bit of extra work, whereas this one is already nice and set up for you. All right, go ahead and tell me what theta is. Remember that we need to pretty much solve for everything on the right-hand side. This is just a number. We need to figure out what that number is. It's about negative 0.53964 something, something, something. And then in order to switch these guys out, I then have to do the inverse sign. So that would be, sorry, the inverse cosine. And I get to flip then my input and my output. Make sure to use your exact value on this guy. Cosine and sine are very specific. And so if you alter the hundredths or thousandths place in a cosine inside of a sine or cosine function, it will drastically change the angle that you get. So just be careful with that. And we get that theta is approximately 123 degrees. Boom. for 3 sig figs. Now, the area of a triangle we have not learned, but it is what we are learning today. Now, we know that the area of a triangle is 1/2 times base times height. That is great if we're talking about a right triangle. Base and height have a perpendicular relationship. So as long as we have a right triangle, base and height, height and base, it doesn't matter which one's which, you're just taking those two right legs and multiplying them together and then dividing it by 2. If we have a non-right triangle, a lot of times what you've had to do probably is like draw in a height and solve for that height, and then you did 30 times the height after you've solved for it. We don't have to do that anymore. There is another formula for finding the area of a triangle, and it's used with trigonometry. Area equals 1/2 AB sine of C. So as always with our trig formulas, this is a relationship of side lengths. So if I were to go in and label a triangle, A, B, C, the angles are uppercase letters, so that's angle C, right? And the side lengths are lowercase letters opposite of the angle. Sine of C would be this angle right here, and A times B would be the two side lengths on either side of angle C. So that's what the area formula means, is that it doesn't have to be specifically side length A. I could have said 1/2 CA sine of B, or 1/2 CB sine of A, as long as I'm taking two side lengths and the angle in between them in order to find this area. So that is the only main thing that you need to remember. So going back up in here and finding an angle that we have, well, we just found an angle. It's always best, always, to use the values that were given to you at the beginning. So I could use this guy and the angle that I found, but I'm using two values that I already calculated for, or that I have calculated for, and potentially there's an error. Potentially I did that wrong. And so it's always smarter to take the values that you know are right. I know that these two side lengths are right and this angle is right, so I'm going to use that in order to solve for this triangle area. 1/2 times 18 times 30 times sine of 27, and we get approximately 123 meters squared. So we're going to go ahead and recap on that area formula, draw it out nice. And write to yourself maybe the angle and two sides of that angle. That's the relationship we're going for here in this triangle formula. All right, if a farmer owns a triangular plot ABC where the lengths are AB, BC, and angle B, find the area of the plot to the nearest integer. What are some things, go ahead and brainstorm before we get started. What are some things that we can do to plan out in this problem? Like, what are some things that we do at the very, very beginning of this problem before we even get started? Hopefully you said draw a diagram, right? Having a diagram drawn, especially for geometry stuff, is super important, but sometimes you'll find even in algebra stuff, it's good to have a diagram. Write out the formula. If it asks you for the area, you can write out, now we have two formulas, of which your area formula, the trigonometry area formula, is in your formula packet. So both of those formulas are in your packet. If you see area of a triangle, then go find that formula and write it down. So I'm going to just draw any triangle. It doesn't matter if your triangle looks to be to scale, right? So I just drew something random. So AB is 120 and BC is 240. Now, 240 is double of 120, but it's shorter in my diagram. That's fine. Just realize that your diagram won't be to scale. This guy, maybe one of these angles looks slightly different than it actually is supposed to look, but that's fine. because we're just getting the relationship of where they all get placed on the triangle. So then we wrote out all of the information that we have. I don't need to think about those anymore. I don't need to reread that problem. And I want to find the area. So I can say area equals question mark to tell myself in the future, I don't need to reread the problem. I need to find the area. Okay, well, the area is equal to 1/2 AB sine of C, which it doesn't have to be A, B, or C, right? I'm not going to use angle C. I'm actually going to use angle B, but it's that idea of the relationship. Um, okay, I think you can do this on your own. Go ahead and find the area of this triangle. The two side lengths that we have are 120 and 240, and then the angle in between them is 130 degrees. Plugging all of those in, we get about 11,031 meters squared. Because it says to the nearest integer. So make sure that you're paying attention to your rounding rules. To the nearest integer means to the nearest whole number.